and welcome to my video solution on question 8 of the B6 2013 mock exam. So part A says find the total area enclosed by the curve C shown unshaded inside the rectangle in figure 1. Okay, so how do we do this one? Well, the first thing is, if we look at the initial line, and I'm just going to consider one section, okay, just this area here, and then to work out the complete areas, I have to multiply it by 4 because of the symmetry. So it will suffice in this case to simply work out the area between here and here, okay, this area here. If I look at the initial line, I'm going to say to myself, as it rotates anti-clockwise, what is the angle it forms here? Okay, so as the initial line rotates, I want to work out the angle. Now initially, the radius is here. As you rotate, the radius gets less and less and less until it gets to 0. And I want to know what the angle is such that this happens as it rotates anti-clockwise from the initial line. Okay, so that's the angle I need to work out. In order to do that, I simply say to myself, what angle makes cos of 2 theta equals to 0? So I solve this very straightforward equation. Cos of 2 theta equals 0. And we know that cos of pi by 2 is 0. And therefore theta is equal to pi by 4. Okay, very important. And now we're ready to go. Now the next thing is, what is the equation, or rather how do we work out the area of the sector if we are given the polar coordinates? The polar equations, very straightforward. The area is given by half the integral of r squared d theta. And we now know that the limits is between 0 and pi by 4. That will give us 1 of the area. We need in total 4. So we simply multiply this by 4. So a half times 4 is 2. That's where the 2 comes from. 0, because initially it's 0. We've rotated to pi by 4. And r squared is simply 9 cos 2 theta. Okay, just squaring r. Now this turns out to be a C4 integration question. We should know how to integrate 9 cos of 2 theta with those limits. So the integral of cos of 2 theta is a half sine of 2 theta, just by recognition. And therefore we have 9 over 2 sine of 2 theta between the limits 0 and pi by 4. So substituting in pi by 4, our upper limit, 2 lots of pi by 4 is pi by 2, sine of pi by 2 is 1. And substituting in 0, you just get 0. So our final answer is 9 over 2 times 2, which is just 9. So a very standard question for part A.